If you start with a u substitution, then u would equal most likely 1 minus sine of x. The derivative of that's got a cosine in it, and we don't have a cosine. Somehow we would need to get a cosine into the problem. There aren't really any identities for just 1 plus sine or 1 minus sine. If this was 1 minus sine squared, then we would have something. But we can get this to become 1 minus sine squared by multiplying by the conjugate. So take the original problem and then multiply the top and the bottom by the conjugate of 1 minus sine of x, which is going to be 1 plus sine of x. And I'll go ahead and multiply out both the numerator and denominator. So the numerator is going to become 1 plus 2 sine of x plus sine squared. The denominator, you just need the first one times the first one is going to be 1. The middle terms are going to cancel, and then it's going to be minus sine squared. And then we can use the identity that 1 minus sine squared is cosine squared. And then we have this. So 1 plus 2 sine of x plus sine squared. Well, now the u substitution isn't looking so good, because if I let the u equal cosine, not cosine squared, but cosine, derivative is going to be sine, which is, this is a lot more than just a single sine. But if I broke this up into 3 fractions, all with the denominator cosine squared, I would have 1 over cosine squared, 2, and then sine of x over cosine squared, and then sine squared over cosine squared. So this one is secant squared, because 1 over cosine is secant, so this one is secant squared. The derivative of tangent secant squared, so we would be able to integrate that. This would be a u substitution, u for the cosine. And this, sine squared over cosine squared, that would require a little more work. We could call this tangent squared, but how do you integrate tangent squared? So I think that we're going to need to use some other identity, like the fact that sine squared is 1 minus cosine squared. So if you replace sine squared with 1 minus cosine squared, and then break that up into 2 fractions, you'd have 1 over cosine squared, so we would have 2 of those. And then we would have negative cosine squared over cosine squared, that's just a 1. Alright, let's change it. So, this is going to be 1 over cosine squared is secant squared, so we need to integrate. And there's one of them right here, and if you take this 1 over cosine squared, there's another one, so there's 2 of them that are secant squared. The middle part we're going to use u substitution. And then the only thing left is this last term, which is negative cosine squared over cosine squared, is negative 1. So we just need to use u substitution for this one. U is equal to the cosine. The derivative of that is negative sine of x. We would then be integrating put the negative sign on the outside. Negative, I can put the 2 on the outside as well. So then this would be the du. This would be u squared. So that means that we would really be integrating u to the negative 2. And that would be a, let's see, add 1 to the exponent's a negative 1. So u to the negative 1 over negative 1, which would then make this be positive. So then that would be 2 over the u. So 2 over the cosine. Alright, now we've just about got it. So the derivative of tangent is secant squared, so the integral of secant squared is tangent. So we've got 2 times tangent of x. For this, we did this u substitution, we ended up with this. A 1 over cosine is secant, so that's really 2 times secant of x. And then for negative 1, that's negative x.